Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we're going to be looking at previous year questions of physics asked in medical and engineering entrance exams in India. Today we're dealing with another important chapter, description of motion in one dimension. This is the same topic as that of the chapter motion in a straight line asked in the grade 12 syllabus of CBSE. Grade 11 CBS syllabus of CBSE. So there are a lot of important questions. Today we'll be looking at some of them in this unit. So here comes our first question. If a body loses half of its velocity on penetrating 3 centimeters in a wooden block, then how much will it penetrate more before coming to rest? So let's look at how we can solve this question asked in 2002. So here, as you can read from this question, the motion can be described in two parts. So now let's look at the first part. In the first part, it says a body loses half of its velocity on penetrating 3 centimeters. So that means we can consider any velocity u to be the initial velocity, and according to the condition, the final velocity v is equal to u by 2. And let's take minus a to be the acceleration in this scenario, since the block is losing speed. So since the body is losing speed, then it's basically deceleration, so we can write it as negative acceleration. And s being the distance traveled will be equal to 3 centimeters. So now we have u, v, a, and s. So the formula that we should be using is the third formula, which we study in motion in a straight line. The formula is v squared equals u squared plus 2as. So since v is u by 2, so we'll write u by 2 squared equals u squared minus 2a times 3. So now we can write the left hand side is u squared by 4, and the right hand side is u squared minus 6a. So if you move on further simplification, you can write u squared on the left hand side as equal to 4u squared minus 24a, basically multiplying 4 on both sides. So taking u squared to the right hand side and 24a to the left hand side, you get 24a as equal to 3u squared. So basically u squared equals 24 by 3a, which is equal to 8a. So now we know the value of u squared as equal to 8a. So we have a relation between initial velocity and acceleration. Now let's look at the second part of this motion. So in this second part, it is asking us how much will it penetrate before coming to rest. So what we do know about this part of the motion is that the initial velocity u will be equal to u by 2, while the final velocity v will be equal to 0. Deceleration occurs with the same rate, and we need to find out the value of s, or the distance traveled. So basically over here we use the formula again, v squared equals u squared plus 2as. In this case, the left hand side is 0, the right hand side is u by 2 the whole square minus 2as. U squared by 4 minus 2as is equal to 0. So u squared by 4 will be equal to 2as. Multiplying both sides by 4, you get u squared equals 8as. So now you can see that u squared equals 8a and u squared equals 8as. What does that mean? We can equate 8as as equal to 8a. We can cancel out 8, we can cancel out 1. So the value of s, that is the distance traveled in the second part, will be 1 centimeters. So therefore, if you look at our options, you can find that option A, 1 centimeter, is the correct option. Let's move on to another question from this chapter. Speeds of two identical cars are u and for u at a specific instant. If the same deceleration is applied on both the cars, the ratio of the respective distances in which the two cars are stopped from that instant is 1:1, 1:4, 1:8, 1:16. Another question asked in 2002, and again a very important one. We need to understand this question in detail. So over here you have two identical cars. Let's say there are two Ferraris of the same make, so they have no problems and they move along similarly. So in this case, one of the Ferraris have a velocity u and the other Ferrari has a velocity of 4u, and they suppose this is at a velocity u and this is at a velocity 4u, and they are at the same position in the same instant of time. Now from here we have applied an acceleration, a negative acceleration, to stop the cars. So that deceleration, we can consider it as -a for both cars since they're of the same model. And you need to find out the distance s. You need to find out the ratio between the distances s1 and s2 such that the two cars are stopped. So that means v equals 0. So in this case we will have two cars, and so we will let's write say car 1, car 2, and then we'll write out the initial velocities and other quantities. So the initial velocity u in car 1, we consider that as u, so that means in car 2 it will be 4u. Final velocity, that is v, is 0 in both cases. The deceleration is -a in both cases, and the distance traveled, we can consider that as s1 and s2. So these are the quantities. Now let's look at car 1. In car 1, we can apply the formula v square equals u square plus 2as. Since the value of v is 0, the left-hand side is 0. In the right-hand side, you will have u square. And then since a is negative, you will write minus 2a times s1. So here, u square equals 2a s1. That means we can write s1 as equal to u squared by 2a. So far, so good. Now we'll find out the expression for the second respective distance, that is s2. So for car 2, we once again write v squared as equal to u squared plus 2as. V is 0, u squared in this case is 4u the whole square minus 2as2. So 16u squared is equal to 2as2. That means s2 equals 16u squared divided by 2a, which is 16 times s1. So therefore, s1 by s2 will be equal to s1 divided by 16 times s1, which is equal to 1 by 16. So s1 is to s2 will be equal to 1 is to 16. So the ratio between the respective distances at which the two cars stop is the ratio 1 is to 16. So therefore, among the four options, option D is the correct option for this question asked in 2002. Let's move on to the next question. From a building, two balls A and B are thrown such that A is thrown upwards and B is thrown downwards. Both happen vertically. If VA and VB are their respective velocities on reaching the ground, then you need to find out the proper relation, whether VB is greater than VA or VA is greater than VB, or are they equal, or are their velocities dependent on their masses. For this question asked in 2002, we will be using the help of a diagram. So over here, let's say this is the precipice of a building, and the height of this building is, say, h, and you have acceleration of gravity g acting on this moment. Now, two balls are thrown. The first ball is A. Now, A is thrown upwards with a speed of u. Now, since gravity is acting on it, it will most likely undergo a projection. It will most likely become zero at some point and then come back to the same height at a velocity u. From here on out, it goes under the influence of gravity until it reaches VA. For VB, it is thrown directly with a speed u, and it reaches the ground at a speed VB. So having understood that, let's find out the expression for both VA and VB. So for ball A, it's projected upward, it reaches height at a speed u, and from there it falls under gravity. So from the building, it's falling under gravity, so the initial velocity is u, the final velocity is VA, acceleration is g, and the height is h. So therefore, using the third law, you can write VA square as equal to u square plus 2gh. So this is the expression for VA square. And believe it or not, it is the same expression for VB square because you're throwing it down with a speed u. So the initial velocity again is u square. And then 2gh is the same because h and g are same. And then the velocity that it reaches is VB, so VB square on the left-hand side. So therefore, since the formula for both VA square and VB square are same on the right-hand side, you can write VA square as equals to VB square. Taking square root on both sides, you can write VA as equal to VB. So therefore, the correct relation in this question is expressed by option B. Option B says that both VA and VB are equal, and that is the correct relation when we are using the diagram and understanding how the balls are moving. So option B is the correct option asked in this is the correct option of this question asked in 2002. Let's look at this question. A car is moving with a speed of 50 kilometers per hour. It can be stopped by brakes after at least 6 meters. If the same car is moving at a speed of 100 kilometers per hour, you need to find out the minimum stopping distance. So, how do we solve this question? Over here, u1, that is the initial velocity that the car moves earlier, is 50 kilometers per hour. Converting that to meter per second, so multiply by 1000 divided by 60 times 60. So zeros get cancelled, so you get 6 cancels with 10, so 10 becomes 5 and 6 becomes 3. So therefore you get 250 divided by 18. So that is equal to 125 divided by 9. So 125 divided by 9 meters per second is the value of u1. And it says it can be stopped by the brakes, so that means v1 will be equal to 0. And the distance that it travels, that is s1, is written as 6 meters. And the deceleration is, A. So now what we can write, we can use the third law of motion. So in the third law, we know that v square equals u square plus 2as. Over here, v is 0, so 0 equals u square. So that means, u square plus 2a times 6. So therefore, now we can write this quantity of acceleration as minus 15625 divided by 972. So it's actually 12 times 81, not 12 times 9, because 9 is getting squared. Don't forget it. So the value of acceleration is minus 15625 divided by 972. You can divide that and you will get something equal to 16.07. I'm going to take that as approximately equal to 16 meters per second square. So the value of acceleration is minus 16 meters per second square. Well, that is the value of the deceleration. Now we need to find out the distance traveled if initial velocity u was 100 kilometers per hour. So now that becomes 100 times 1,000 divided by 60 into 60. So both zeros get cancelled. You get 1,000 by 36, which is equal to 250 divided by 9 meters per second. And once again, it's getting stopped, so therefore v2 is equal to 0. S2 is unknown, and the value of a remains the same, so that's minus 16 meters per second square. Once again, we use the third law. So what is the third law? V square equals u square plus 2as. On putting in the quantities, 0 equals u square minus 2 times 16 times s. So therefore 32s will be equal to u square, which is 250 divided by 9 whole square. So therefore s will be equal to 250 times 250 divided by 32 times, well, 9 times 9 is 81. So this is basically simplified too, so we can just simplify it ourselves as well. So it's 32 becomes 16, so that's 125. 16 again divides with 250, so the bottom side becomes 8, and the numerator becomes 125. So 125 times 125 is 15625 divided by 8 times 81, that is 648. So so now it's 15625 divided by 648. You will get approximately a value that is equal to 24 meters per second. So therefore S2 is equal to 24 meters per second is the correct option. I mean, it's not 24 meters per second because we're talking about the distance, so it'll be 24 meters only. So therefore the value of S2, that is the value of stopping distance when a car is moving at a speed of 100 kilometers per hour, is option C, 24 meters. So that is the correct answer for this question asked in 2003. Now let's look at the final question of this episode. A ball is released from the top of a tower of height h meters. It takes t seconds to reach the ground. What is the position of the ball in t by 3 seconds? So once again, let's draw it with a diagram to make it look easier. So this is a tower. It has a height h, and the height h is covered by a ball in t seconds. Now at time t by 3 seconds, the same ball will cover a distance of x. We need to find out the position of the ball in t by 3 seconds with respect to the ground. So how do we solve this question? We will solve this question using the second equation of motion. The second equation goes like this: s is equal to ut plus half AT squared. Over here, we will write, in case 1, we will write for the total time period. So S here is equal to H. U is 0 because it is released. So therefore, U will be equal to 0. So 0 times T is 0 plus half times A here is G, acceleration due to gravity. And then you have capital T squared because that is the total time period. So therefore, from this equation, you can write 2H as equal to GT squared. Now, it is important to note this relation down because we will be coming back to it. Now, let's take the second case. In the second case, the time is T by 3. Total time period divided by 3. At this case, we will use the second formula once again. So, S, in this case, that is X, is equal to U times T is again 0 because it's released, plus half G T by 3 squared. So therefore, you have GT squared divided by 18 because 3 squared gives you 9. 9 times 2 is 18. So basically, you get 18x as equal to GT squared. Remember that in the last equation, we wrote 2h as equal to GT squared. Here we get 18x as equal to GT squared. So 2h is equal to 18x. From here onwards, you can just divide both sides by 2. H will be equal to 9 times x. So therefore, x equals h by 9. Now, you might think this to be the answer, but no. This is the height from the top of the tower. The height from the ground of the tower will be h minus h by 9, which is equal to 8h by 9. So 8h by 9 is the correct answer to this question. So therefore, amongst the options, option C, 8h by 9, is the correct option for this question asked in 2004. That concludes this episode of NEET JEE Main. For more of our videos on NEET and on JEE regarding chemistry, you can hit the link in the description down below that goes to the playlist. For watching more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. We have a lot of amazing content and useful content here, so do subscribe to us, and you can also hit the notifications button in order to get updated about our latest content. So until the next webisode, take care, stay safe, bye-bye for now.